Good morning, good afternoon, and good evening, and welcome to Energy Speaks Back, powered by B2B Energy. My name is Paul Webb, and I'm the founder of B2B Energy, and I'm also your host. And weekly, I present to you energy experts from around the world. Welcome to episode 161. Our purpose, as always, is to provide a good understanding of energy management knowledge from around the world, which is available today for us to deliver savings that impact on our planet. Welcome, energy enthusiasts, to another enlightening episode of Energy Speaks Back, where we delve deep into our guests' origin and their knowledge in the industry. Please engage with comments and the poll after this podcast. Today, I interview the Managing Director of the most efficient fan in the world. Yes, a bold statement, but we will be exploring that quote in detail today. Our guest today provides valuable insights into the world of moving volumes of air more efficiently. So without any further ado, let's push the air efficiently with Arjan De Voogd from Novenco. Good afternoon, Arjan. How are you today?
I'm very good, Paul. Thank you very much. Yeah, thanks for having me in your podcast.
And I'm hesitating because it's getting that name right, because it isn't spelt the right way for pronunciation, is it? If that makes sense.
No, not when you're British. No, yeah,
No.
yeah,
And
yeah.
what's the origin of the name?
So I'm originally from the Netherlands. I grew up there, born and bred. Yeah, and then when I was doing my mechanical engineering, I did my final 6 months training period in the UK.
Right.
I met a wonderful lady there, and the rest is history, as
And
it goes sometimes.
that's always the way, isn't it? I met a beautiful
Yeah.
girl in Thailand, and that's why I'm linked to Thailand, because I love going back to Thailand, and I will probably one day stay there, like yourself.
Yeah, there you go.
Have you moved around much?
No, we're living in Wiltshire, rural Wiltshire. Really enjoy it here. I come from a busy city life. I grew up near Rotterdam. Now we're here, enjoying life. Got a family here, so we haven't had too much reason to move around. A lot of our work is obviously in London, so I do a bit of travel, but
Yeah.
yeah.
And where's your company based?
Right, so the company I work for is a Danish company. They have a big factory in Denmark, their own R&D department, and then I run the UK office, which is based in Melksham, which is somewhere between Bath and Swindon, so to say.
Yeah.
Lovely part of the world.
So
Yeah.
do you have to travel backwards and forwards to the head office and things?
Yeah, we do frequently. Yeah, especially to take clients back to sort of see where all the magic happens.
Yeah.
You know,
And I'm not going to give too much away, because there is some magic. Because I've seen your presentation. The presentation alone, the quality of that is magical. But we will come back to that. So
yeah,
we have met. I don't really meet many of my people that I interview, which is really great. We've met, so we've done some studies in one of my clients' properties, and so we met and we've had some chats, which is great. So, but for the benefit of our audience today, can you tell us a bit about your origin story and your background? What brought you into this industry? And I know you've talked about your university travels and things, but what has brought you into this industry alone?
So after I did mechanical engineering, I wanted to carry on with further education. And in Holland, there was a university that basically offered me doing work and study at the same time. And some of my accreditations would be given through the work I did. And the agency that held me onto this, they couldn't find a suitable job. And I came to, actually, straight after my initial training, I came to the company Novenco. And I remember having a conversation with the director at the time, and he said, you either finish your training and then you come and work for us, or you come and work for us and I'll train you. And being a student, being broke, I thought that was a fantastic idea. So I joined the company. I joined them in Holland, and I was working for them in the ventilation department, specifically for life safety systems.
Mm-hmm.
underground car parks, smoke ventilation, and then
Yeah.
high-rise buildings as well. And then I enjoy that and moved on from there. And then after a few years, I moved to the UK. I left the company. But a year later, my old director came back and he said, "Are you still in the UK?" And I said, "Yeah, I'm still in the UK and I'm not planning on moving back to the Netherlands." He said, "Well, would you mind joining the company again?" So I did. It's always been very technically sales driven and predominantly focused on life safety systems. And then in 2010, they launched this wonderful product, which had very high efficiencies, very, very high efficiencies. And the R&D department, when they launched it, they said, "Right, sales guys, you've got 2 years, and then the whole world is going to copy us and they're going to do the same thing." Well, to date, that still hasn't happened. So we must have done something right with the
Yeah, yeah.
patents. But it
And
got us
kept moving
going.
things forward.
That's it. Yeah,
Yeah.
that's it. I think the bar has been set very high with the product that we have, and that's how we got into the energy efficiencies and the energy savings, when we've really been driving yeah, especially since we had the sustainability goals being sharpened and sharpened and being set. The bar has been risen higher and higher.
Yeah.
A lot of companies have shown a lot more interest in it, and for us, it's become a real business opportunity. And for me, it's just great to be involved with something that makes the world better. I mean, I've got 5 children myself, and they need a world to live in, and it's great that you can do your bit in reducing the emissions, and it's great to be part of the journey. So the company's been very loyal to me, and therefore I can be very loyal to the company. And they have a fantastic product. It really is a great product, something you can really believe in. It's great, yeah.
You talked about originally the technology they had was all about life safety. When was the transition into the more energy management and the efficiency element?
So the transition was, so the life safety was more it's a system, and we still do that, selling systems, which is all to do with compliancy. And of course, when it comes down to smoke ventilation, when there's a fire in a building, to extract smoke from a building, keeping people safe. We all know the tragedy of the Grenfell. That has a big effect on our industry. But really, in a system, there's only a small part of it is the fan movement, because that's just a few fans on the roof or in the basement or somewhere. The real change came when the factory launched that product in 2010, when we had fan efficiencies achieving up to 92%, and there was no other fan manufacturer that ever achieved that high efficiency levels. And that's when the real drive started to come as a business. We need to be green. We need to promote this product. We need to bring this into the market. And it was a complete different business stream, a different business avenue for us. But as a group, it's been we've been very technically driven people traditionally, and that's why we got a very well, there's not really a lot of magic to it, because in the end of the day, it's an axial flow fan, and that technology has been around for donkey's years. But it's the way how we've been able to refine that technology. But then now we need to bring it to the attention of the world. And that's why I greatly appreciate these sort of opportunities that we really like to tell other people about. This is a great product, and this is a good way of saving your energy. Yeah.
And I've seen the product, that the quality in just to look, I likened it to like a Formula One racing car. When we looked at them fans, they're immaculate, aren't they? The way they've been finished and the way they're designed. It's
because our R&D guys, when they developed the product, they used the same software as Rolls-Royce uses to develop their jet engines, and it made an aerodynamic product. And aerodynamics are, in my view, pleasing to the eye. It looks smooth. It looks nice. There's something. A good racing car looks good to the eye, and it's all because it's designed with airflow patterns and efficiencies. And that's really what we did. Like I said, it's an axial flow fan, but the same with a Formula One car. It's got a normal combustion engine in it, yet it's not normal because everything is refined and precision engineered. And that's those principles. That's what we've applied to a fan. It was funny. We've recently just done it's one of a job here in the UK by a big manufacturing plant of butter, and they after they replaced half their fans, they rang me up and they said we just don't get it. On average, we have a reduction of 62% energy, but we know you're moving the same amount of air. What's the magic? I said, well, no magic. Come round and we'll show you our fan and we tell you exactly what it is and how we do it. And so they came round and we showed them all the details of the fan. And yeah, it's just amazing. I mean, 62% moving the same amount of air. And on top of that, it was a great benefit. It makes a lot less noise. And they said that we can really see a difference when our guys are working in the factory, that we can just hear a lot less noise from the fans rumbling along. And it's those kind of applications. It's the low-hanging fruits. Where we really try to get our product out in the market and push it.
Yeah. Can you go through, without giving away the magic, is there some steps you can talk to us about and to educate some of the experts out there, to give them, enough education to call you as such? But is there some steps that we can be looking at regarding what you're actually trying to achieve? What does your product try to achieve?
So our product, the aim of the product is to move the same amount of air that needs to be moved to whatever your application is, industrial, air, whatever it is, to move the same quantity of air with as little energy as possible. Mm-hmm. Okay, and you can make big energy savings in different ways. And typically, when you talk about air movement, so air movement is actually a huge number of the total global energy consumption. If you put that, I don't know the percentages exactly, but it is quite significant for all the energy. So we can reduce that bit significantly by making better efficiencies, encapsulating a huge energy reduction, obviously a carbon footprint. So for moving air, there's 4 elements. So first of all, you've got a system. It has to move air from A to B through a system as a supplier, through different grills, different pieces of duct, and so on and so forth. And to do that, you need a fan, a motor, and something to control the motor. Now, if you want to create savings, obviously a system that's got nice low velocities running through and very little bends and nice straight flows, that means there's not a lot of resistance, low resistance. That means you don't need as much energy to move that quantity of air. Then thirdly, the other 3 bits, they're all encapsulated in the same thing, really. It's the fan, the motor, and the drive. Now, with a fan, a typical fan, if you have a traditional centrifugal fan, which is what's often needed to move higher pressure systems through, or air through systems with higher pressures, they are not very efficient. They can be as low as 60% efficiency, and all the ones even less. And secondly, you can go the motor. So if you've got an older system with an IE1 motor where efficiency wasn't really the thing, that's where you can gain an energy efficiency. And then thirdly, it's your controls. If you just turn your fan on and it's on at full speed, I see more and more offices, they have like CO control or temperature control, and depending on that, they vary the speed of the instrument. And obviously, reducing your speed of the fan will significantly decrease the uses of energy. Now, the beauty is that by taking one fan out with the motor and the drive and replacing that with a new fan with motor and drive, you encapsulate the potential energy savings, the 3-in-1, which is your big energy saving, in a very easy way. So it's not a lot of work. It's, typically once you guys have done it a few times, it's a day's work to take an old fan out, put a new one in, you're back up and running. And that's those 3 elements. So by putting in a high efficient motor, a more efficient fan, controlling it through a high efficient frequency inverter, and only running it at the speed that you need, you encapsulate a huge potential of that reduction of your footprint.
How quickly can we go from A to B regarding this? So we do the survey, we do the analysis. Is it how quickly can we start the survey, from instruction, start to implement this program? How easy it? Because it, when we done the survey at that particular site, we done some measurement. Would you like to do more measurement? That was just a sample measurement. I presume you would like to do more analysis prior to that actually implementation.
Yes and no. We like doing at least so the hardest thing that we found, there's two things that are difficult. One is the actual design data of your original piece of equipment,
Yeah,
because obviously you need to make sure that whatever you put in is able to deliver the same amount of air that was the original design intent.
yeah.
And then the other big problem that we usually have is getting your equipment to the location of installing it, because sometimes they're put in such places that the building, we've recently been in a building where literally the building was built around the air handling unit and there was no way you could get a
Around the
product
fan as such. Yeah,
effectively. Yeah,
yeah.
yeah. So they are often your two most difficult things. So the process is typically we will come and do, well, if the design data is not available, then we will come and do some measurements, or we can take you take the measurements that can be anyone to confirm the volume flow rate and the pressures. That gives us a duty point, and we can then make a selection. If we have the existing details of how much that the fan is using currently, that's great, because then we can do a proper return on investment calculation,
Yeah.
where we can work out the exact savings that we can predict. And usually for if you have a traditional centrifugal type fan and you replace that and it's located in the right location, I'll come on to that later as well, where you have our solution can use the dynamic pressure as well as the static pressure, whereas centrifugal fans, they only work with static pressure. If the fan is located in the right place, then it just becomes a matter of doing the maths and the calculation, which is very simple. We've got a piece of software to do so.
Yeah.
So that's a matter of days to turn that around, and then it's getting the approval. Then there's a production time of the equipment, which is typically 6 to 8 weeks. And then, like I said, the actual installation work, so your downtime, on a bad day, it's a day's work. Once you've done it a good few times and the accessibility is fine, it can be as short as 4 hours. So that's another benefit. There's obviously a lot of critical applications that need the air being moved, and it can just be done quite quickly.
And do we see instant payback as soon as it's
instant?
Instant savings there and then.
Yeah, instant there and then. And that was the thing. These guys that came around, I think they replaced 10 fans, and the minute they turned the new fan on, they'd see that, because it was all controlled via BMS, and they could see the consumption significantly reduced. And there it worked out in a return of investment of around about 1 year. So a very, very short period of time.
And you mentioned before about the percentage. If you've got a property that's got air handling units, ventilation plant, it's the likelihood of that percentage. That's going to be the major percentage of energy consumption in that building, isn't it? If it's going to be the ventilation or air handling units.
Yeah, in most buildings, yes, especially for industrial applications, you see that ventilation is one of the main consumers of energy. Of course, you've got the likes of pumps and lighting and what have you, and thankfully there's many different ways of making savings and energy reductions in there. Yeah, our area of expertise is obviously in the air movement, and it's really exciting to be part of that journey. Like where you can really go to your clients and say, we've got something, and that's why we're confident and we can really believe in the product, because we've seen it time and time again, where just every time it has proven to be a success. Yeah. So we say, have a fan, try it out. We do this proof of concept where you can just stick one in and you see the difference yourself. And
what percentage do you find the properties have already been sort of oversized, over generating the duty on them's too much anyway? Because when typical design site, we always put a plus of 5 or 10% on top of the duty, don't we, on pumps and fans, to make sure that we've got enough coverage on them, don't we?
Yeah, so that depends a bit on the application, and it's a bit hard for me to comment on, because where our expertise is the fan itself,
Yeah.
and normally in application they'd like to have some have 5, some have 10% additional flow. But like I said, traditionally the older type systems, they were on off, so it was running 100%. That's it.
Yeah, exactly.
But with fan laws, and this is one of the great things of adding a control device that you can turn the unit down, because obviously reducing your volume flow rate by linear reduces the pressure by the power of 2, and it reduces your power consumption by the power of 3 to the cubes. So a small reduction in your volume flow rate is a significant reduction in your energy usage. That's just basic fan laws. That applies to everyone. That's not necessarily one product. That's just the fan laws of the world, how it works. So by just adding that capability to it, whatever offices very often they have air handling units running, and now they're controlling with CO sensors. And we actually got one in our office, and it's interesting. And the system can just automatically ramp down and only do what it needs to do. Adding that intelligence to it is a huge impact already. And so it's combining controls, your motor, because if you move from a traditional, an old-fashioned motor to a new IE4 or IE5 permanent magnetic motor, something like that. Let me just turn that off. Yeah, I do apologize. Yeah.
That's all right.
Yeah.
Just shows you're important. Someone's chasing you.
Yeah. How do you do that with the fan movement? No, yeah. It actually, that was such an exciting call to get, when you literally get a company, a big company, and they say, we just don't get it. How do you do it? And yeah, like I said, it's not magic. It's refining existing technology, and that's one thing that I think that I find so encouraging about this whole journey.
Yeah,
you don't necessarily have to reinvent the wheel. You don't have to start from scratch with something. Just look at what you've got, and this in my view is applies to any industry you work in, anything you do. Just look at what you've got and stand back and think, how can we make this better to improve it? And I think by doing that, you can go strides forward. Yeah.
And 9 times out of 10, we need it anyway. We've got to have this ventilation. You've got to have this air flow, etc. So we can't do away with it, and we can't say, well, because we can't do away with it, that doesn't mean we can't do nothing with it. And that's what
Correct.
you're doing, and you're going to do something to make it more efficient.
Yeah. Like I said, our objective is to move the same amount of air using an awful lot less energy.
And what was the 3 areas? I know when you've done the presentations, you broke it down into 3 blocks. One is controls, obviously.
Yeah.
Can you go through those 3 points for us again, just to summarize them?
Yeah. So the three areas that you can capsulate by fan chains, well, there are 4 in total.
Right.
One is your drive, the second is your motor, the third is your fan, and the fourth is your system.
Right.
The combination of those 4 things determine how much energy you need to move the required quantity of air.
Yeah.
And to make that energy saving, the big reductions are in the drive, the way you control it, as we discussed, the motor, by having a more efficient motor, the fan, having the latest technology on the fan. And those 3 things are your biggest savers of energy usage. You can combine by taking out one old fan and its controls, replacing it with one new one, and that's it.
Yeah.
Of course, then there's things such as redundancy and backup, or then you stick in 2, each doing half the required duty or whatever. There's different ways you can deal with that. But yeah, that's the big thing. Now, one other thing, a bit technical maybe, but it might be interesting to some. So, like I said earlier, there's different types of fans. There's also fans available with integrated drives on their motors, and they're definitely a big step forward from the traditional centrifugal bell-driven units. The problem with those is, or the disadvantage is, they are built for high pressure applications, and they can only use with the static pressure. Now, because in an axial flow fan, the air moves through the unit. If you are able to discharge into the duct, so ideally you have your fan located at the end of the application going straight into the duct, you're not losing all the velocity pressures, the dynamic losses,
Right.
which means you can then work with your total pressures. And that is where we see the big, if of course you can put an actual fan both in the middle of a unit, but the ideal scenario is that you discharge the air. It's just looking, again, standing back, looking, how can I make this most efficient? And if you're able to put that in a place where it discharges into a duct and it maintains the dynamic losses, it's using physics in your advantage, if that makes sense. Yeah. It's not necessarily the product, but it's just, the laws of physics we all have to deal with that can also be beneficial to you.
And there's loads of different application requirements, isn't there? There's different, pharmaceutical probably to labs and office buildings
Yeah,
to
we've even
factories. Yeah, I'm sure there's a wide range of various applications that you have to be challenged to address.
yeah. I think one of the most exciting that we've recently been involved with is carbon capture plant. So we've had our fans were used to move the air through the means that capture the carbon and store it deep into the ground.
Wow.
Which is also used as an offset program for many of the big companies. But yeah, obviously the more efficient your fan is, the less energy it uses to do what it needs to do.
Yeah.
That was a fantastic project for us to work on as well and to be involved with.
And what country was that in?
In Iceland.
Right.
It's been made operational in Iceland. But yeah.
Wow. And it's up and running now.
Yeah. I'm not supposed to give names, but yeah, it's
okay. Well, I won't delve into that. While you was talking about the 3 areas or the 4 areas, one thing I was thinking about, and I thought you talk about the system.
Yeah.
When you talk about the system, do you include things like the filters? So the filters must play quite a big part in this story, mustn't they?
Yeah, it's a very good point. If your filters are clogged up, they will create more resistance. Yeah. And going back to the fan laws, so your additional resistance is to the power of 2 compared with the volume flow rate, but it's to the cube compared to the power consumption. So as a clogged up filter will have a huge impact on how much energy that the fan needs to move the correct quantity of air, which is usually controlled with sensors, with the BMS system that control the fan speed up and down to make sure that it achieves that volume. It's all about a volume of air being moved through, typically. Yeah. And if your filters are clogged, the fan will have to work much harder and uses a lot more energy. So it's the same principle as if your air pipe gets squeezed, you have to work harder to breathe and to stay alive, and it's for a fan system no difference.
Because I've seen nowadays we've got more efficient filters we can start to use, but obviously there's a premium on them, like everything nowadays, isn't there? And do you look at that? When you look at these systems, do you possibly incorporate the system? That's what I was trying to get at. When you're not just focusing on the fan, you look all the way along that system to see what could impact on the energy efficiency in that system.
Yeah, we typically do when we are on a site or even involved with new build applications, because we're trying to help consultancies and so on and so forth, advise them in those things. But we as a business, we're quite focused, our target area with the fan specialist and whoever makes the air handling unit and all the bits or whatever the application, like for example, this carbon capture plant, our speciality is the fan that we've given them to then build into their application. And that's a similar thing. Yes. And it's nice to share your knowledge and your experience, because we get to see lots of different, I really enjoyed the site visit we had with yourself a little while ago. But you see so many different applications. But yeah, and one thing that's opened my eyes is that it's surprising where the air needs moving mechanically. what a vital part it is for so many industries and so many businesses. So yeah, it's exciting to be involved with that. And yeah, like I said earlier, I think we all have our duty to look after the planet and to leave a wonderful place for our families, our children, and to be able to be part of that is a great thing. Yeah.
Yeah. And your role within the organization, are you the managing director of UK?
Yeah, it's grown. We were a small outlet, and at one point it was just me, and the business has grown. We've picked up more and more work, which no doubt what has really helped from that perspective is that when the energy prices jumped, there is obviously not just
yeah.
the focus is double. It's a two-edged sword. And we as a business, because we target a lot or we speak a lot with companies that are signed up to things like science-based targets and things like that, which we too signed up to, and it's a great initiative to be part of, to really drill down in the minute detail of your business. Where are we producing a carbon footprint that we can reduce? Again, our product has another big benefit that it's 98% recyclable. So it's been independently certified, which is the benefit of having the casing is made of steel, galvanized steel usually, and then the hub is all aluminium, and then the motor is obviously predominantly metals that can be recycled.
Yeah.
So yeah, even though it's got a long lifetime, once it dies, it can be remade.
What's the life cycle of it?
So a lot of this depends on the bearings, and the
Right.
bearings have a normal operation time of about 70,000 hours life cycle. So it obviously depends, and that's at full speed. If the speed is half, that doubles. So again, it can be as long as 20 years, or even longer.
Yeah.
But yeah,
And staff, what I'm presuming you design, install, maintain as well. You don't just sell the product. You do the whole complete turnkey approach to that, yeah?
Yeah, it's something we can do, but again, typically we can do the whole thing but we use subcontractors to do the installation work. We don't employ those people direct,
right?
Because it's a very low maintenance product. If you break down where the maintenance is, the fan itself, it can run like 300 years or something like that, a huge amount of time. And then you add on the motor and the drive, and then the weakest link is the bearings. And that comes from motors, and the motor can also, it's all replaceable. You can take it apart. You can, it's good old good old mechanics like some from that perspective. There isn't a lot of cleverness in it. It's just a motor with the fan hub direct onto the shaft. There's no bits about it. And then you've got your drive, and the drive needs maintenance. But typically drives are, there's lots of drives in a building that run pumps, run other things, run belts, and you name it. And it all falls under the same maintenance package. It's all stuff we can offer, but again, we like to focus on with specialists in the fans. We've worked out a product that's fantastic in its energy savings. And that's what we like to focus on. That's our area where we're the master.
And what typical sort of payback periods do we look at regarding this?
So it depends on the operation time. So if your application is 24/7, in many cases, it's less than a year.
Wow.
If you have an application where it only runs during events, or where it only runs office hours, if it only runs 12 out of 24 hours, it takes twice as long. But we find there's a lot, because there are so many businesses that are committed to reducing their carbon footprint, because they have to, they've signed up to it, they want to drive this factor. It's not the return of investment is not usually the highest priority. with the people we deal with.
What is the priority that's on their mind?
Reduction of your carbon footprint,
Right.
reducing your energy consumption. That's the main
So not cost,
driver.
carbon.
That's it.
That's what you're
Yeah,
referring to.
yeah,
Yeah, sorry.
yeah,
Yeah.
yeah,
Wow.
yeah,
That's interesting to know because, you know, normally the focus is on let's reduce cost first and then follow on to be green afterwards.
yeah. And the two go hand in hand with this
Yeah.
one.
Yeah.
But you find with big, we've had a lot of big international businesses where we've done in a country. It seems that a lot of work seems to happen in India there, where we do a changeover, and then yeah, they go, we need to do this all over the world, and then it gets rolled out to other manufacturing facilities they own and run in other places in the world.
Because your product does have the remit to go all over the world. Is nearly every organization around the world has got ventilation plant that they
Yeah,
need
yeah.
controlling and reducing.
Yeah, and of course there is an area where we're our best application is when you need the higher flow rates, because that's also where you're saving. I mean, I always say I can't save 15 kilowatt on a 2 kilowatt motor, yeah,
Right.
but I can save 15 kilowatt on a 37 kilowatt motor.
Yeah.
Yeah, you see, and that is typically the kind of reductions you're talking about. And if you look at that from installing that in a new application, you see a huge difference in impact on your incoming power supply requirements. Some applications, they need secondary power supply, so your generator size hugely decreases as well because you need less. So the knock-on effect is not just money, it's not just size of the equipment itself, but it's also your incoming supplies that feed the equipment.
Brilliant.
Yeah.
Do you know what? This is a really interesting subject, and I like the way you guys. And I did mention it to you when we done the survey. I like the way you break it out into those areas when you've done your presentation because it makes it a lot clearer, and it
Yeah.
should demonstrates the full opportunity of this technology. So it's come to that time where I put you on the spot, and I know we've all
Right.
done that side of it. Is there anything that you feel that you can give back to the industry today as a takeaway for someone listening to this episode?
I think I sort of touch base on that. I think everyone, wherever you are, have an opportunity to make this world a bit better from a carbon emission perspective. And you don't have to go back to the drawing board or come with something genius that's completely new. Of course,
Yeah.
those things are there, but just find what you're doing that uses a lot of energy, stand back and see what can I do to just make this better so that it needs less energy to do the same thing that it's already doing.
Mm.
I think that for me has been the big eye opener, that when people ask me the question, what's the magic? And the answer is, there is no magic. This is what our forefathers have been doing for years.
Yeah.
We've just refined it. We've just, and that's what I think you can do with so many different applications that are already there.
Yeah.
Yeah.
And while you was just going through that, I was just thinking to myself, don't reinvent the wheel. And that's what we try to do, isn't it? We try to reinvent the wheel when the wheel's already there. We just
Yeah.
got to make it more efficient. We've got to
That's
move,
it.
as you said, you've said it more than once today about moving that air from A to B more efficiently.
Yeah.
And we do that by not reinventing the system.
Correct. Yeah. It's when you go back and you see the wheel and it's got lots of sharp edges. Well, what if I
Just make them
turn that wheel
smoother.
perfectly
Yeah.
circle? Let's see what
Yeah.
that does. And hey,
Yeah.
it rolls perfectly fine now. And that's just a stupid example, but
Yeah, of
it
course it
sort
is. Yeah.
of comes down to wherever you are, whatever your application, your field of application is. I don't believe, I do believe in that. Sometimes you have to restart again,
Yeah.
but just look at what you got and see how can you improve that. That would be my main take back. Yeah.
Brilliant. I really like that. How do we find out more about you? Obviously, you're part of the B2B Energy Network, and everyone in the network gets exposure to you? How does everyone else listen to it? You know, someone's going to listen to this today, and would like to know, how do I find out more? Well, how do you promote yourself? You got a website and things?
Yeah, so that would be the first place I recommend anyone to go. Like I said, traditionally, our company has been very good technically and not very good in the marketing and the sales. As it happens, we're actually going to the EMEX exhibition tomorrow
Uh-huh.
in the Excel in London. Again, it's just raising awareness of what we do. Of course, there's our website, novenco-building.com, where more information can be found. This week, or last week, our R&D guys, they launched a very handy guide in how to do validation things, and they made lots of videos on how to do it on any application.
And where can we see them on YouTube?
They are on YouTube, but the best way is just to go on the website again.
Yeah.
And on the website we have it's on the tools, and there's also a software package where you can make the selections. I've spoken with various people, and they go, "Yeah, I've heard this all before." And then you go, "Okay, well, let's do a selection." And then we get our software up. It's going to be downloaded by anyone. And they go, "All right, give me a fan on that flow and that pressure." And then you can hear them on the background on their own computer doing the same thing. You go, "Okay, so what's your energy consumption on that?" And you go, 25.3. And you go, "What?" Yeah, it's really, that is pretty good, isn't it? So it's exciting, and it's
Yeah.
every time you hear that, it sort of gives you a little kick of, and that's why I enjoy working for the company. I always have done, and it's what makes you motivated to make many other people aware in whatever way it is. So it's good. Yeah.
So I'm really pleased you're doing EMEX. I will be EMEX for 2 days visiting. I normally have a stand there, but this time around I'm going to be absorbing the networking and the technologies that's going to be on show there. So I will definitely. What stand you're going to be on?
B50, we're right next to the networking space.
Right.
So we look forward to welcoming you and anyone else who's
Yes,
joining.
definitely.
Yeah.
We'll be seeing you there. So Arjan, thank you very much for your time today. It's been very, very interesting. This is going to be the start of many, because I can see we can get. I'd like to get more involved with the technology and maybe get you to do some more like the presentation. I think your presentation needs to go live on YouTube as well, because it's very valuable, and I learned a lot just from that presentation, how you break it all out, and it's very, very valuable. So thank you very much for coming, and please come back again in the near future.
Yeah, it's a pleasure, Paul, and I appreciate your feedback, and really appreciate the opportunity as well you've given us. So greatly supportive of your work. I'm very grateful that we our paths met. It's quite an amazing way, really, how my colleague Joe managed to get all of you guys. So, yeah. So it's good, and thank you so much, and we look forward to doing whatever it takes to bring things further forward. Yeah.
Excellent. So, and lastly, please, you and your family stay safe in these times.
Thank you. Yeah, same to you. Yeah, thank you, Paul.
Thank you to my guest for joining me on Energy Speaks Back. I hope you found today's insights valuable. And don't forget, please, listen to the previous episodes, because they're full of insights to help you make a real impact on energy efficiency. Together we can drive change and make a difference to the environment and our planet. So thank you. Once again, that leaves me with one more thing to say. Please, you and your family, stay safe in these times.